Imagine a train so fast that it almost breaks the sound barrier. Well, this might have sounded like science fiction a few decades ago, but it's now becoming a reality. Enter Hyperloop, an ultra-fast transport system proposed by none other than billionaire and innovator Elon Musk. Once complete, this engineering marvel will be 3.5 times faster than any of Japan's Shinkansen bullet trains and will see passengers travel more than 700 miles in less than an hour. But what makes the Hyperloop so brilliant? And how come it will change your life in the near future? The Elon Musk vision. The Hyperloop envisioned by Elon Musk was to enable super-fast travel between San Francisco and Los Angeles, where passengers would be carried in special launching pods through a low air pressure tunnel. For these pods to safely travel at near the speed of sound, the trains would have to rely on magnetic levitation, a mechanism that minimizes the frictional forces between the pod and the tube of the tunnel. In theory, it sounds good. But for such a vast and complex system to be actualized, overcoming frictional forces is a major priority. Because as you know, friction causes the gradual wear, tear, and damage of structural components. So how did Elon solve this? He proposed two methods. The first one was to construct a series of large permanent magnets that would suspend the pod and keep it from coming into contact with the bottom of the tube. But that idea was quickly dismissed by Musk, who, after doing the math, realized that the costs would soar through the roof. The second and more viable option was to use air bearings to create an air cushion underneath the pod. This air would then support the pods and eliminate any frictional resistance. A lot of engineers loved this idea, and that's why most Hyperloop concepts are adopting this design today. How the Hyperloop train works. Aside from frictional resistance between the pod and the tube, engineers working on the Hyperloop also had to deal with a much greater enemy: air resistance. You see, air resistance at top speeds is extremely dangerous to the structural integrity of a Hyperloop train. One proposed option was to use a vacuum pump to create a vacuum inside the tube. But a vacuum pump over such a long distance? That's going to be quite expensive to build, let alone maintain. Such a design would be too catastrophic to a company's bottom line. What's the point of building a Hyperloop worth billions of dollars if you can't profit off it anyway? So, to find a more viable solution, Elon proposed in his 2013 Hyperloop Alpha concept that a very low pressure environment be created within the tube. We're talking 100 pascals max. Now, let's put this into perspective, shall we? That's roughly 1/6 of the atmospheric pressure on Mars, or as we like to call it, Elon's home planet. That pressure is also 1/1000th of the atmospheric pressure on Earth at sea level, meaning that air resistance is greatly reduced. So, after the initial acceleration, a Hyperloop pod in such a low-pressure environment should be able to glide smoothly without applying any additional thrust. One would only need to decelerate the pod once it arrives at its destination. Designing the pods. Even though the pods essentially travel through a low-pressure environment, engineers contributing to Musk's open-source Hyperloop concept still have to come up with innovative pod designs. They have to construct a pod with excellent aerodynamic capabilities that is made mainly from carbon fiber. And trust us when we say there's a lot that goes into the science of pod engineering. To cut the costs of material used, Musk proposed the cross-sectional area of the pods to be about the same as the cross-section area of the tube. This way, the walls of the pods are always close to the walls of the tube. But this creates another problem. You see, when the walls are so close together, they make the pod behave like a syringe, so that when the pod starts moving, it pushes the column of air in front rather than letting the air flow around it. This makes the pod slow down, and that's not desirable. So Musk further proposed that the pods be equipped with an electric compressor fan that pumps all the high-pressure air accumulating at the front towards the back. And because the air is pumped underneath the pod, it also creates the air cushion we mentioned earlier that reduces drag. What about comfort? Well, the Great One believes that the pods should be designed to exert a maximum inertia acceleration of 0.5 grams. That's about 3 times the inertia acceleration that a passenger on a private jet experiences during takeoff. Designing the Hyperloop tunnels. With the future of Hyperloop looking ever promising, Hyperloop tunnels are being constructed with the finest materials that money can buy. The construction of the tunnel is based upon 3 main features: the ability to be airtight, the strength, and of course, the durability. To meet these parameters, a majority of Hyperloop tubes are made primarily from steel. Other companies in the race towards Hyperloop dominance, on the other hand, have opted to go for the ultra-high-performance steel fiber-reinforced concrete, commonly known as UHPFRC. So now we find that most standard Hyperloop system concepts are made up of large tubes of concrete and steel. These tubes are then constructed on top of pylons for elevation, with a few ground and underground segments incorporated as well. In fact, the elevated system in a Hyperloop tunnel is actually put in place to, and you won't believe this, lower the cost of buying land upon which the Hyperloop tunnels are built. Having an elevated system also ensures that the tunnel is protected from the forces of man and nature. You know, the occasional earthquake, a deer wandering aimlessly into the tunnel area, or maybe even a car unexpectedly crashing into one of the walls. The best material for a Hyperloop tunnel. In recent times, composite materials have proven a better substitute for steel, especially in the aerospace industry. They bring many structural advantages to the table, and let's face it, they look cooler. Take for example the fact that composite materials are much lighter than steel, but still surpass all the structural requirements of the latter. The use of composite materials will also mean that composite Hyperloop tubes will be thicker than steel tubes. This is great when it comes to making the Hyperloop system rigid and less prone to buckling effects. In short, if you're riding in a Hyperloop train, then theoretically, you should experience a smooth ride all the way. Composite materials are also far less sensitive to temperature changes, meaning they have fewer problems accommodating heat expansion. Such a design ensures structural integrity and passenger safety remain a top priority. The benefits of Musk's Hyperloop system. According to Hyperloop's leading contender, Virgin Hyperloop One, commercializing Hyperloop technology could be the saving grace that we've all been waiting for. Not only will this high-speed technology shake up and revolutionize the transport sector as we know it, but it could also potentially save the environment. Yes, that's right. You see, if every passenger traveling between 500 to 1,000 miles on a flight decides to use a Hyperloop train, carbon emissions could be reduced by a staggering 58% annually. Plus, let's not forget the aspect of time. According to Musk, these types of trains could make living and working in two different cities a reality. A shorter flight time would relieve you of jet lag, enable you to spend more time with your family, focus on your health and well-being, and spend those precious hours growing your business. The latest development in the Hyperloop industry. In November 2020, the Hyperloop industry made its first real step to commercialization. 2 human passengers managed to successfully ride a Hyperloop train for the first time ever. The test was carried out along a 500-meter track located north of Las Vegas, tested by Virgin Hyperloop One. During the pioneering test, the pod managed to clock an impressive 107 miles per hour in just under 6 seconds, with the ride lasting a total of 15 seconds. It's important to remember that in a much longer tube, a Hyperloop pod can clock over 600 miles per hour. The only downside to this is that it gets a much slower acceleration at the start due to the effects of G-forces, just like how trains pick up speed with time. With the test completed successfully, it appears that Hyperloop trains are relatively safe. Now all that's left is for one of these competing companies to tap into the commercial success and brilliance of the Hyperloop transport system. Personally, we can't wait to have a Hyperloop transport system right in our city. So are you looking to book a date on a Hyperloop train? You might just be in luck. The first Hyperloop train should be scheduled for opening sometime in late 2021. Who knows? Perhaps you could be the first to hop on board.